Hi friends, my name's E and today we're going to be continuing to hack on the Gleam language. So if you watched the last video, you saw that we're trying to add a new feature to Gleam here. So if we pull up the ticket, we are trying to generate TypeScript type definitions for Gleam modules when compiling to JavaScript. So yesterday we made kind of a huge mess, just copy pasting a bunch of code from how this is done in Erlang, as well as the current JavaScript module. But off camera, I've gone ahead and kind of cleaned up the mess that we started yesterday. So if you remember yesterday, what I had done is I had flattened out all of these functions so that they were no longer part of like some sort of box. But that was a big mistake. And so what I've done off camera is kind of gone through and put them back in a box, put them tied to a struct, and now all part of an implementation. And the other thing I realized as I was going through everything is every time I mentioned the word generic in reference to Rust yesterday, that was just wrong. I'm pretty sure these are not actually generics, but instead has to do with marking the life cycle of an object in Rust. So if you watch that and you were cringing and you were like, wow, this guy doesn't know what he's talking about, you're absolutely right. So gone off camera, kind of cleaned this up, typed everything so that there's no more warnings, hopefully, in this, other than not using certain variables. I've gone ahead and implemented some missing functions with just some to-dos to remind ourselves. And most importantly, what I've gone ahead is added a bunch of tests. So what we can do is I can run these here using cargo test, and we can kind of see where we're at. So yep, definitely a bunch of unused functions at the moment, which is what those warnings are about. And if we wait just a hot sec, all right. So you can see we've added some functions that are taking in some Gleam code and then outputting the outputted TypeScript definition. So here's like one for to do. So you can see that we have a public function called go, which just returns a to do. And the equivalent TypeScript type definition for this is export function go, which just returns an any. And well, that looks correct. So we've already got some tests that we're happy to check in. Here's another one that has to do with our tuples, and this also looks correct. But we've also have some that are currently panicking, and these are having to do with the to-dos that we currently have. So we can go through and make sure that any place that's currently panicking, we can go through, but we can see that nulls are correct. This does not look correctly formatted at all. Looks like we're missing a comma in space when we have multiple arguments in a multiple generics, TypeScript generics. And then we're also missing a space when we export const. So this is not consta. This should be const a is a list of any. All right. And it looks like, yep, we are still panicking on public external functions, which I did a little bit of research off camera. I understand now how those are being generated. And then the other thing to note here is this is where the lack of importing is causing us issues. So in this test here, what's happened is in another module, it's defined a one type with a two constructor. And this is correct. The main function here does return a one type, but nowhere in here have we actually imported one from the other module. So we need to go through and we definitely need to track those imports and have some sort of equivalent. Yep. So we got some functions, or sorry, we got some tests that we can start to kind of work through here. And so the things I probably want to start with, so we got our bit strings. Let's just fix some of the formatting issues because that should be nice and fast and easy. So let's look for export const in our file today. So if we find that, well, any place else? Okay, well, easy enough. Now we can rerun the tests, see how we're doing. And we can also run something where we can start to check some of these in if we know that they're correct. So I'll show you how we can do that in just a sec. So if we scroll up to where we saw that export const going wrong before, okay, there we go. So now these are coming in correctly. And let's check. A is a list of any, that is correct, and B is a list of number, that is also correct. Snaps, we got it right. Is there anything else? Yes, and all these are also coming in correctly. So A is true, B is Boolean, or A is Boolean, B is Boolean, and C is null. Looks fine and dandy. All right. So to start checking some of these in, you'll see that there's instructions here to update the snapshots, run cargo insta review. And here, using this command, we can actually start to review these, as well as say, yes, these are correct, and some of these are wrong. So let's run this, and I think this should give us an interactive workflow. And let's just run this to make sure. Yep, okay, the review command is the interactive version. So is this one correct? Nope. This is not correct yet because we're not doing the importing. So we're going to just skip. Is this one correct? Nope, we're missing the space, missing the import, missing the import. That is correct. Nice. So we got UTF code point and bit string. Ooh, just kidding. What I realize here is these are completely unqualified, as in like it's just trying to use some global type UTF code point and bit string, and this actually should be UTF-8 code point. So we actually need to be importing these from the prelude module. So we're not doing that yet, so we cannot mark this correct. So we need to skip this. This one is correct, and we can just check it in. This one's correct. Not correct. We haven't handled externals. This one does look good. This one does look good. Skip. Looks good. And we're also missing some spaces here after class. So in this one, basically what this test is testing for is overriding the what the true, false, and nil are with custom constructors. And you can see that that's happening here with these custom types, but we're missing some spaces. So we'll skip that one. Not having the import from prelude, so that's wrong. Not handling that. Cool. So at least we now checked in some of these, so they won't be marked as errors in the future. So let's look for export class just to fix that spacing. Yep, here it is. Save. And so now, if we run this again, oh, actually, I think I have to run cargo test to regenerate. Ooh. All right. So now, hopefully, in that function, we should be seeing a space. Yeah, perfect. And this one would be correct, except we are not importing this custom type. So this is another thing that we need to import from the prelude. All right, so we're in a good place now. At least all the quick formatting stuff is all in place. And so now what we need to do is basically we need to know when should we be importing that prelude. And I have an idea around how we might want to do this. So if I go back to our type printer that we did in the last episode, and I kind of take a look at these. One, should this be UTF code point or UTF-8 code point? Let's just check Erlang real fast. Erlang.rs. And if we look at for UTF code point or type printer, yep, okay, it is just UTF code point. So got that one right. But for these kind of like custom types that aren't built into TypeScript, like number or string or Boolean, what I think I want to do is just prefix these with prelude. Prelude. Let's just make sure I spell that correctly. I know it's in the templates. Okay, this is prelude. And let's just do prelude.utf code point, prelude.bitstring, and prelude.list, prelude.result. Oh, whoops. Doing that on the wrong side. And this is where we're missing that comma. Grab that while we're at it. And so what we've done here is we've said, hey, these are all coming from the prelude. And now what we need to just do is when we detect that we're using one of these custom prelude types, we just need to add import star as prelude from prelude.d.ts. So if we add this at the very top of all the generated bits, we'll just get all those preludes for us. We don't have to worry about destructuring this into list and results and stuff like that. We can just give it an alias, and it will just make our life pretty easy. So if we go back to how JavaScript was doing this, in its generator, it has this usage tracker. And inside here, it basically just has a bunch of Booleans on what various features were used, and it will use this usage tracker to know what type of imports, I believe, to add. So if we take a look at how tracker is used here, yep. So if tracker OK used, after we go through every single statement, then we know to add all this stuff. And instead, what I think we're going to do is just, like I said, import all. So our usage tracker can be much simpler, I believe. So let's copy this. And let's give ourselves a usage tracker inside our TypeScript file. And then instead of OK and all these things, let's just say prelude used. I think all these bits can go away for now. And if we go down, I think I have some comment out code that we can uncomment out. Also, from the last video, I said that I would go through and find out what all the reserved words in TypeScript are. And so here they are. Any Boolean constructor, declare, all that stuff. So I've just replaced the Erlang ones with the TypeScript ones. So that happened off camera. And there we go. So we're going to grab our tracker here, usage tracker. And now we'll have access to this tracker as we go through. I believe it's complaining that, yep, never used. And what we can say is when we find a list type or any other type, we can just add it to our, we use this prelude. So see how JavaScript does this. Let's see when it knows when list is used. Oh, okay. So I assume this is in its either statement generator or the expression generator is the thing that maybe gets past this tracker. So if we look for expression, I assume, yep, okay. So the tracker is passed into the expression generator. We don't need to do that. So what we just need to do is if any of the incoming or outgoing types come from the prelude, we'll just do it manually ourselves. So do we want to pass our type printer this usage? Because the type printer is the thing that's going to know if these are coming in or out. I think that will make our lives relatively easy. So first off, let's make sure that we are referring to the type printer that we have access to so that we're not just generating a new one each time. What is it complaining about? Cannot capture dynamic environment of function item. I'll come back to that. I don't think I've seen that error in Rust yet. What if we make this not mutating? Okay, didn't help. Because in here, let's just say tracker. So what we're going to do is we're going to pass a pointer to this tracker inside the type printer constructor. And so our type printer now, instead of taking nothing, will now take a pointer to a tracker. Okay. So it wants us to track the lifetime usage of this. This is where my abilities in Rust really hit a wall. This is one of the things I'm still trying to learn. So I'm just going to ignore the error, just like in the last video, and maybe solve this off camera. But you can kind of see what we're trying to do here is pass that tracker down to the type printer. And now in our type printer, when we're going through things and we're printing out in our prelude type, here what we can do is call that tracker and say that, hey, this thing's been used. So self.tracker dot prelude used. Now, this is not true in every single instance. So we're just going to do that in the places that make sense. And let's see, the other place is bit string. And we need to do it in list. And we need to do it in result. All right, there we go. So now we'll know, hey, when we're printing out all these types, by the end of it, did we need to actually import the prelude? Which means at the end of here, after end of processing every single statement, we should have printed out all the types and we should know, hey, was this prelude used or not? So we can do that. And let's say if self.tracker.prelude used, let's just push to the very top here our fancy docvec helper. And so up here, we'll need that import star as prelude from, and I believe it's just up one directory, prelude.d.ts, but we'll find that out if that's correct or not. In fact, we don't even need this docvec. We can just make this to doc. And then we can push an empty line afterwards. Okay. So let's take a look at our test again. See how this looks. Ooh, all right. So thankfully, Rust has very good errors and looks like it won't let us run the test until we actually fix that issue that I wanted to kind of skip. So looks like we're going to add a tracker here, 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 and here. And what do we have to do next? Okay. So we need to type the tracker with that. See what our next error is. So there's a place where we're currently instantiating a type printer on line 297 that we're not passing in the tracker. That's because we're not calling self dot. So here we need our type printer. Okay. And here we're going to associate it on line 147. And I think what we're going to say is okay. All right, so we're finally, looks like we're down to our last error here, which is basically cannot capture dynamic environment from function item. Use the or closure form instead. Well, Rust has this very nice utility where it can actually explain these errors in more detail. So let's go see what it says. So y is a variable here. Cannot use this. To fix this error, you can replace the function with the closure. Okay. Or replace the captured variable in constant static item. Okay, let's do that second one. Let's go to the error and let's just say let say printed type is equal to this, and let's just put in the printed type. Still does not like that. Well, let's do the first thing it said. Okay. Let equals that, and then inside a bit. And if we make this, did we already try not making this mutatable? Yep. So what's interesting is we've already used this in a few other places. And we're not getting those errors over there. This is the only place. Ah, okay, I see. So we are inside this dynamic, like, excuse me, this lambda function inside this function. So we are inside this other bit. That's what's different about us. So self may change out from under us. Is that the issue? So let us just do this. Let type printer equals self dot type printer. And then instead of doing self dot, will it like that now? No. And if we put it inside here, will it like it now? Nope. I believe you can't make it constant because constants only can be at the top level. Static A. Okay, not gonna work. Inner functions do not have access to their containing environment. To fix this error, you can replace the function with a closure. So we need to access this type printer. let's see. Can we prime this with the type printer? Meaning, could this be a function that takes a function and returns a function? Uh, don't think Rust is going to love that for us. Hmm. I kind of want to just get rid of this thing and instead just do this inside of map using a closure as it was referring to. So we get arg. All right. How we're doing? I assume got it. So this is a tuple. All right. All right. Now it likes us. Now it likes us. So we can go back to this. And let's see. Well, let us run our test now. Yeah. Well, spoke too soon. So let's see. Lifetime of A. This is another uh, tracking bit. We do need to make this a mutating, so we're allowed to mutate it. So that is absolutely correct. So we need to mark it as mutatable. Nope, doesn't like that. What's the next error? Okay, so we want to mark this as mutatable. All right. And we now have a next error, I think. Let's see what cargo wants to tell us for this. Got it. So we cannot both track. We can't have tracker ourselves and pass it in uh, because basically it's not going to love us for doing that. So how do we fix this? We do this. Also, why do we need to mutate the type printer? That shouldn't be something that we need to do. Okay. So now it's just complaining that we didn't type the tracker correctly because this needs to be now a so close. Maybe I have to pause the recording here to figure out exactly what I'm doing here. Ultimately, well, We did make it a mutating. Oh, the type printer needs to. I see. The type printer is the thing that's manipulating it. So the type printer is the one that needs to mark this as mutatable. Maybe I've just been manipulating the wrong thing this entire time. Yep. So let's see. We have a pointer to a pointer, and it is needing just a single. So if we look at where the type printer is instantiated, right. And we're back to the other error. Fix one error, get to the next one. Let's see. So we are allowed to have our tracker be a mutatable pointer. So that's what this is. We pass it into the type printer, and we pass it into ourselves so that we can ask it questions. Technically, we don't need to be able to mutate it. But may not like that. Okay, so I think I'm going to have to press pause on this recording. Sorry about that. Let me figure out how to fix this off camera, and I'll be back in just a sec. Well, we're back. Sorry about that. That took me probably 20, 30 minutes to kind of figure out, hit up some people on Discord and ask some questions to get past this. So what I was trying to do just now, not really allowed in Rust. You can't really have that kind of shared object that is with a field and also referred to by another object at the same time, not without using some trickiness. So what I realized after talking it through was ultimately the TypeScript generator doesn't actually need access to that tracker. Instead, it can just use some public functions on the type printer, because the only thing that's manipulating this object is the type printer. So what I've done is simplified this so that there's no longer a tracker field on the TypeScript generator. And if we go to the type printer here, you'll see that the tracker is now only on the type printer. And the reason why you see this ref counted or reference counted pointer plus a ref cell is basically when I didn't use that, I had to mark every single self here is mutatable. So I had to do mute here, 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 here. And then once I did that here, well, then that started populating back out to the TypeScript generator, and I had to mark all of these as mutatable. And that just seemed like a pain in the butt. So instead, I'm just wrapping with a reference counted pointer to the usage tracker. That way we can just call borrow mutation, which will let us borrow the object and allow us to mutate it, do that ref cell, and then that we just call that, but right before we manipulate the object. So we just call that, and then we can do our prelude used, and then down here, we're just exporting a function called prelude used, which basically just goes, grabs the object, and returns that field on that struct. All right, so back to it. So now we have our type printer, and we'll know when the prelude is added. And so now we can check prelude used. So now instead of this being a field accessor, we're just calling a function. So when our type printer says the prelude has been used, we'll be adding it here. So if we run our tests, we should hopefully see now in those generated outputs that we should be adding an import statement. Let's see if that's happening. We are. Now we are doing it in the wrong order. So this should come first, this line here. That should definitely come before the exports, but very cool to see that that is in there. Yep, exactly. So that's fine. We can definitely fix that. And when we're not using a prelude, it's not included. So that's awesome. And oh, right, this custom type is not happening here. So we need to import custom type from the prelude. Let's just make sure that that's in the prelude template here. We should see custom type somewhere in here. Oh no, we don't see what custom type is. That's unfortunate. Let's search the code base for custom type, see where that is coming from. Okay, so it's definitely coming from the prelude, but looks like it's just not defined in the TypeScript definition. Let's see if we can find the JavaScript. Okay, so it's importing the custom type from prelude MJS. So if we look at maybe prelude.js, and oh, here we go. Okay, so I think what we need to do is just add this in here. So we just need to export a custom type. And let me just, yep, it's definitely not in here. All right. So let's export a class called custom type. We can even make this abstract, but let's avoid that for now. So this is going to have an inspect function, which returns a string. And it's going to have a with fields function, which takes in fields, which I don't know what those are. And it returns this. So it looks like it's calling this.constructor, which would return a new instance. And so this should is the keyword in TypeScript to say, hey, when you call this thing, it's actually going to return a new instance of this type. And what's cool is when you extend this, this will refer to the extended object, not this custom type. Now we just need to figure out what fields are here. So fields are, I see. So fields here is basically an object where the keys are keys of this, and the value is a proper value for this. I'm not great. I would know. It's basically you have to do like t extends this, key of is an object with a key of t going to t at, or this at t, something like that. But I'm not very good at this. So what I'll do is add that in, maybe a to do of like making that better. But for now, we're just going to mark it as any, and they'll do. I'll make this better off camera. But for now, it should be good. And what is the error that it's saying? Okay, no ESLint. That's fine. Okay. So at least now we have it in our prelude, which means that we need to make sure that we are adding that. So let us go back to our TypeScript file, or TypeScript here. And I realize that we're pushing, and instead what we want to do is unshift, if that's available to us. Move it to the front. Nope. That's fine. Again, what we can do is we can see what JavaScript's doing here, because we're basically just copy pasting what JavaScript did. So if we jump back to our JavaScript buffer and we look at down here, so statements, I see. So it's just doing imports, then the line, then the statements, then a line. That's fine. So let us jump back to JavaScript, TypeScript. So this will be this whole thing, followed by a line, followed by our statements, followed by a line. Otherwise, it will be our statements followed by a line, and then looks like we need to call toDoc on that statement here. Make it all pretty. And oops, this needs to be wrapped with also a docvec. Okay. And now it's complaining that does not need to be mutatable. Yep, sounds good. Love it when we don't need to mutate. So now we run our test again and we take a look at the generated outputs. We should see the import before the actual exports. There we go. We got an import followed by our exports. And we may want to add two here. Sorry, two new lines so that we get a little bit of spacing between the two. Yep, that would make this easier to read as well. Okay, that's easy enough. So what we can just do is two new lines. Go again. There we go. And beautiful. Now we have our import, two new lines, and the rest of the statements. Import, export A, export B. And these are both now coming from prelude and prefixed. So this is perfect, actually. Yep, prelude.utf code point, prelude.bitstring. Oh my god, amazing. So now what we need to do is also add, when we have a custom type, we need to import that. So let us go up to where we refer to custom type. Now, because this is not in our type printer, which is currently checking if the prelude's been used, we may need our own tracker, or we may need to somehow stick this into the type printer. Indeed. Yep. This is the only place we refer to this. Yes. What we're going to do is just a little bit of grossness. We're just going to add a new public function here. Oh, that should have been public too. And we're just going to say set prelude used. And this is going to do that. Oops. And make sure we're returning a unit. And it's saying that it's never used. That's absolutely fine. And what we can do now is just tell the type printer is now kind of doing double duty. It is both a usage tracker for the prelude as well as our beautiful type printer. So let's just do self.typeprinter.set prelude used. Okay. So if we run our test again, we should hopefully now see right at the top of those classes, we should be importing the prelude. Ooh, and we also need to change this to do prelude.custom type. Let's see if that at least got imported. Almost there. Okay, beautiful. Okie dokie. So we're now importing our prelude. These will all be prefixed once we compile again. Now we can just finally start working on the parts that are erroring out. But so far, I feel like we've done a lot of good work. Okay. This video is getting a little bit long again. So what I figure what we can do is just implement a couple of these to-dos for the external functions and external type, possibly. Well, external type we may still continue to fix or skip. We also have this type alias. And this should be easy enough for us to add. So let's just do this one. So when we get a type alias, that means inside the Gleam code, it's going to look something like, public type header is equal to a list of, what's a header? String. So we're just basically creating a type alias. So header is now an alias for list of this tuple. And so the equivalent in TypeScript is going to be export type header list string. And this is going to be prelude.list. So we need to transform this to that. Shouldn't be too bad. So this is, we can just do probably a docvec where all we're saying here is export type. And then we need to do the type safe name, or we need to convert this alias into something that is safe. So we already have that here in the maybe escape identifier docs, but we also have something else inside here that lets us ts type safe name. Yeah, ts safe type name. Exactly. So here we can just call ts type safe name, passing in the alias, and then space after that, or space equals space. And then finally, we just need to do the self.typeprinter print that type, please, followed by a semicolon. Now let's see what it's yelling us about. Oh, we want to wrap this with an OK. And let's see, expected string found that. So could we just do that? Cannot return value referencing temporary value. Returns a value reference a data owned by the current function. Then let's see if we can just pass in like this, which should make it so that, yep. And if we do it here, okay, let's just clone it. Make our life easy. Okie dokie. Now, what I realize is we don't have a test yet for this, as far as I'm aware. So let's jump into our tests and let's add a new test file. We'll call this type alias.rs. So inside this type alias, we're just going to copy paste another one. So this, we don't actually need to assert any JavaScript stuff because it only matters for TypeScript, these aliases. And here we're going to basically just do the exact thing that we just did. Pub type headers is equal to a list of, whoops, string. Okay. Excellent. And now we just need to add this to our list of files that we're testing. And hopefully now, yep, should be good. So if we run this, hopefully now that will mean this test will run and we should see the output. Okay. So it looks like we did not fix that issue with the temporary value. So let's go take a look at that. Close out some of these buffers along the way. Oh no, okay. So, nope, didn't fix it. Cannot return value referencing temporary value. I see. Type safe type name. This takes in a string and returns a new string. Temporary value created here. Let's just call it. Well, this feel like this has been a video of you watching me kind of debug Rust errors. Apologies. Oh, what if I instead called toDoc on this? Okay, that didn't do it. Thought I got it. I see. So type name is borrowed there. Let's see where else this is used. So we're manually calling document string around it. Name here is a slice instead of the capital S string. Okay. Let's see if we can just call document string, wrap ourselves around it. See if that does anything for us. Hey, it does. Okay. Now let's see if our tests are working. Okay. We can start to check some of these in as well as I think, oh, there it was. So we import the prelude and we say export type headers is equal to a prelude list of this tuple, string of string. This is it exactly. Okay, amazing. So our type alias is also working. And we are kind of good to go. So I'm going to call it quits here. Well, actually, let's ceremoniously check in some of these. So what's left for us to do, probably in part 3 and the last video, is to just handle the imports. So this one's not working yet because of the lack of imports. This one is working. Yep, the result type is all good here. So we'll accept this. Not importing, not importing. This one is all good. We'll accept that. We are also not handling external functions, so we'll do that as well in the next video. This one looks correct, so we will accept this. Our type aliases are working no problem, so we'll accept that as well. Not importing. This one is all good now. We're importing those custom types, so we'll accept that. This is all working. And we are still not handling external functions, and that's it. Okay, with external functions and imports, that is it, at least for this video. Again, if you are into Gleam, highly recommend going to gleam.run, taking a look at the docs, very well documented. You can go to docs, getting started, or the language tour, and this is pretty awesome content. And if you want to get involved, feel free to join the community here. and we have this awesome Discord. So yeah, I'll see you online and see you in the next video. Cheers, y'all.